Hey everyone, hope you all are doing great. I am Partharu, Events and Program Manager for MS Reactor India. And yes, I welcome you all for our today's event, Mastering Power BI Models and Relationships. But before we start our today's event, let's go through our code of conduct. We are all here to learn together, participate together. So please be respectful of other people's views, understanding the differences, be kind and considerate in a way we all engage. Yes, we do encourage you all to participate. Please drop all your questions in the comment section. And I would not like to take much more time. I'd like to invite Rajendra, our MVP and speaker for today's event. Hey, hi Rajendra, how are you doing?
Hi Path, I'm doing good. How are you?
I'm all good, all well. Rajendra, let's do one small activity today. Hey
Yes.
everyone, can you just drop in the comment section from what region, what place you all are joining in today? And meanwhile, yes, Rajendra,
Yeah.
I've brought the deck up to the screen,
Okay.
and the floor is all yours.
Thank you. Thank you, Path. Let me share my screen.
Yes,
Let me know once you can confirm
yeah,
me that my screen is visible. Yeah.
it's visible now. Yeah,
Thank you. Hello, everyone. First of all, thanks to the Microsoft Reactor and Path for giving this opportunity to speak on this mastering Power BI models and relationship. And before moving on to the topic, this is for whoever interested to learn on the relationship side. Still, if there is any confusions, how to bring the models or else what kind of a relationships we have, like a learning part, like different types of relationships we have. Once the relationships are built, then only we can do the further visualizations, whatever the further activities. So in the today's topic, maybe if you are an expert, it's just a learning curve, and also whoever the new people on this Power BI mastering or else whatever you are trying to learn on this tool. It's something like we are going to work on the data modeling part. I'm going to showcase you some examples, and I will walk you through what are the model related like a cardinalities that we have, and also the what happen if you are not providing any kind of a relationship between two tables. And also whoever not familiar with this kind of a schemas that we have in Microsoft Power BI, like a two schemas, I will try to explain it in a brief because as per the time permits. And we will do, I mean, I will take your queries if you have any queries or else any kind of a confusions still on the mastering this Power BI and relationship manner in this model view. Fine. Before moving on to this, I'll just try to give myself a brief intro. I am Rajendra Ongole. I'm a Microsoft Data Platform MVP and a super user at Microsoft Fabric community where I can share answers to different people in different regions. And I'm a Microsoft certified trainer and 14 years of experience on working with, started with Microsoft Tech Stack, like SSIS I started, and slowly I moved to the Microsoft Fabric and Power BI combination. And I'm a peer lead at Bosch, Hyderabad, and I'm also one of the organizer Digitech Community Group, where in the next week we are going to have an event of Global Power Platform Bootcamp. So you can learn many things there on the Microsoft Azure Tech Stack as well. And if you want to catch me up on the right hand side, my personal link, email, and also LinkedIn, you can connect me there, and data analytics blog. So I'm writing the blogs and new features and functionalities which I have come across my experience. I can just try to put those things in my blog post. You can reach me there too. So it is very interesting. Fine. Before moving on to the content, as I said, we'll try to understand the data modeling relationships. So, what type of relationships are there? Why modeling is required here? So, what happen if you're not creating the connections or as relationship between two tables? I mean, table to the table. As per the real time, we will not work with one table. We will work with the multiple tables. What happen if you're not providing any relationship? How the visual should be looks like? And what is an unconnected or disconnected tables? So how it looks like? So why we are calling it as a disconnected? And suppose if it is disconnected, and what are the ways to bring the connections? Like to bring the connections by identifying the common column. So we are going to discuss that part too. And as I mentioned, star schema designing principles are there. So which is very important, star and snowflake schema. Whenever if you're working on the modeling part, we have to choose to go either the star schema approach, which is a better performance prospect and the feasibility of loading the data into your reporting part. And one more schema is there, Snowflake schema is design also there. So how we are trying to configure or else try to get it in the form of Snowflake schema. What is the disadvantages? Like what happen if we can move on to the Snowflake schema? How we are going to set the relationship? That's a kind of how we are going to manage the relationship in the technically, and what type of a DAX relationship functions if you have more connections or more tables, what are the relationships we have. We are going to discuss on this, and evolution. So what kind of an evolutions mechanism we will use it while working on the data modeling prospect. So don't hesitate. If you have any queries, please post it in the chat box. I'm ready to help you. If you know, I can answer it. If there is some different question, I can just try to reach out to you later. Okay, fine. Let's try to understand the model part. So see here, data modeling is very, very important whenever if you are extracting multiple tables into your Power BI desktop application. In real time, we will not work with one single table, like to build the visualizations or else to work on the data business rules, like a business use cases. We will try to extract different tables from different data source systems too. So we need to identify right connections or else relationships, mappings between the two tables. Otherwise, if you're not bringing the right relationship, we will see the total values of, maybe if I assume that I have two tables, sales table is there one side, another table is the country table is there, which is maintaining country level data. I want to see the country wise sales. If I don't have a connection, I can see the totals of each and every country the same value, which is not a right output to the business terms. So we need to bring a right filters by using these connections only. We have to bring some mapping, identifying the common fields, and we need to bring the relationship between two tables if you're working on. Like that, we have four types of relationships, cardinalities we can say, like one to many to one, and vice versa. Like many to many relationship is also there. Four types of cardinalities. So what is the default cardinality we are going to discuss, and why it is default cardinality. And before moving on to the understanding part of cardinality, I have something for you to understand. Like whoever familiar with the PICE, I mean like a primary key is foreign key, that is well and good. And I'll just try to showcase to you. So how we are going to detect the facts and also the dimension tables too. And please observe here what the processing part relationship identification. We need to identify the right categorical data like dimension tables, which is going to maintain. And also we need to maintain facts too. Like maybe if I have a table with more metric information, and it is going to hold some of the duplication of the data duplication of your table. That table we are going to consider as an fact table. I will tell you some trick to identify the fact table also. Like example, one of the sales table is there which is maintaining multiple metrics, numbers related like sales amount, quantity, profit, cost about cost value, cost of goods and services, and so on. Along with, it's going to maintain some important foreign key duplicates, data denormalized information too. So how we are going to identify those details I'm going to discuss, and also what type of relationship which is better. As I said, there are some default cardinalities as well. As I mentioned, when you are choosing the table itself, auto detect it, and it will try to bring in the form of one to many or many to one. How we are going to identify what is one, what is many. Still, if there is any confusion by this session, right, you'll definitely get an idea and you'll try to map it on your reporting part as well. And what are the ways, what happen if I'm not providing any categorical data to get it filtered with another metric level data. So I'm going to showcase to you how the data will be get filtered, and based on the product or based on the some other categorical stuff. And very important, as I said, identify and identify as well as um, mastering on this relationship or else a model based on very important topics, primary key identification, foreign key, and there are types of facts. And also here in the set, as a set, star schema, snowflake schema is there. And I'm going to provide you some relationships. So example kind of a thing. And what is a dimension table? Still, if there is no clarity about this concept, working on the modeling part will be very messy for us. So I will explain it in a brief, and also I can showcase to you in the practical once we can get started where one of the Power BI file I'm going to open it, I can explain it how it looks like primary key and foreign key. So see here, I just try to come up with one example instead of reading the theoretical part. Please focus here on the table part. Person table is there. Example. Okay, this is an example. I'm holding four columns: person ID, last name, first name, and age. In this table, person ID column, this particular column is maintaining unique records, unique rows, and it is not having any null data. Though there is a smaller data set, three records, I'm not maintaining any null or else blank data, blank rows. That kind of an ID column, we are going to consider it as a primary key. So in my person's table, person ID, which is maintain the unique records, no repetition, and there is no blank. This table, I'm going to treat it as an primary key of this person's table. Okay, one, unique. Likewise, we have another key column, that is foreign key. Suppose, as I said, I want to map my person table with order table here to bring how many orders of this particular, by combining the last name, first name, how many orders has been created or else done. I want to see that analysis. I want to combine it. And such scenario, if you focus on orders table, similar column person ID is there. The same person, Peterson, is having two different orders. Same person, two different orders. I want to join this second table with the first. In such a scenario, orders table, right? Order table, person ID column is going to maintain is a foreign key for you. And order ID column is a primary key because it's maintaining the unique. And maybe from this order, maybe suborders table will be get having a relationship with one side to any side. But here on this example, person table and address table, person ID column is going to be an person table, person ID is a primary key. Order table person ID column is going to become a foreign key because we have a duplicates and the data part. Maybe if there is any nulls or else some information is there, we're going to consider that key column, person ID column as a foreign key here. Okay, it's a simple way to understand instead of reading the technical things, right? I mean, understanding part. So, person table having the person ID with unique, we are calling it as a primary, and orders table person ID is calling person ID column is maintaining the duplicates. Three is repeated twice. We are going to call this particular ID column as foreign key. Let's try to move on to the understanding part of fact table. So these are the base part. Once you get understand the fact and dimension, it's an as simple as easy to build the data relationships on your Power BI model view. Please observe here fact table, which is going to hold a complete measures, metric information, like a example. If you can ask me, like a sales amount, quantity. These are all details will comes under the measures, metrics. And even in the fact table, it has been segregated, separated as types of fact: additive, semi-additive, non-additive. And there is one more fact is the factless fact table. I'm going to discuss in the later. But types of fact, if you can ask, three types of fact: additive, semi-additive, non-additive. And coming to the additive. So example, quantities, sales amount, I can perform any kind of a summarization values. Like I can perform the aggregations like summation, average, min value to find out the lowest value, highest value, max value, or even the median value. It will support any type of an aggregated functions. Example, I have written sum or else average. So in my next slide, if you're observing on the right hand side, these are the aggregation functions which are supported on Power BI side, like sum, average, min, max, count, distinct count, and so on. Then what is the semi-additive? So additive fact is going to support all types of aggregation. Then what about the semi-additive? Semi-additive facts are those, it will be support few aggregation functions only, not everything. Example, if you can ask me, like product ID or else a country IDs. I can perform either it is a count or else distinct count. I cannot perform the summation on the top of it. You cannot perform it. Here I have provided an example details, bank account details. You cannot apply the summation on the top of bank balance. You can use it as a minimum balance I'm maintaining in my account or maximum amount I want to see. So this is an example. Only few aggregation functions it will be get supported for semi-additive facts. Like that, one more fact, non-additive fact. We cannot perform any of the aggregation functions on the top of it, which is listed on my right hand side, sum, average, minimum value, max, and so on. But it is also a number. We can perform a kind of, I mean, like divisions, like finding out the percentages. Like example, attendance on a month. Maybe I want to say an attendance percentage for the last month. I can see, I can tell that people are else a user, 70% or else 100% attendance is there. So we will calculate it, but it is not going to perform any of the aggregation functions on the top of it, either sum or else average, whatever the list I have provided in the right hand side. Example is like a ratios finding, calculations part, divisions. So these are non-additive facts. Three types of facts representing the numeric part, matrix part, additive, semi-additive, non-additive. And coming to this fact less fact table, if you're observing this, a fact table that doesn't contain any of the measure. Example, if you can ask me, like a product ID, like maybe in my date table, I have a date keys. I cannot perform any of the aggregations on the top, but it looks like a number. Product ID, maybe it looks like a number. We are not going to perform, it's a whole number. We will not perform any of the aggregations like a sum, average, and so on, right? That's one we will call it as a fact less fact table. Then coming to this dimension, if you can understand the facts, which is going to maintain the numbers matrix, there is one more category, categorical table like dimensions. Dimension table is going to maintain the description of your like a model, like an example I have provided as a product table, like categorical table, example like a segment table. So it's going to hold the values in the form of categories, the values, like a description. It is going to provide some information. That table, we are going to call it as a dimension table. So please keep in mind, dimension table always maintains a primary key relationship with directly connected to your fact table. That means fact table is going to hold the foreign key. Dimension table or lookup table, another alternate name is sometimes we will get in our requirements lookup table. If you can ask, lookup table means dimension table. So it's going to hold the primary key here, primary key relationship with your fact model, fact relationships. Okay, let's try to understand the star schema design here. So here assume that centrally you have a sales table with the fact related information which is holding all id columns like item key, time id, branch id, location, and remaining very important metrics like quantity sold, amount, average sales, which is a matrix. These are all metrics. Assume that there is one more, sales amount, profit, and so on. So this fact table, it is directly connected to your surrounded dimension tables. If you can see, time, location, item, branch, these are all dimension tables which is maintaining the primary key fields like a time id, location id, and so on. And it is directly communicating to your centrally located fact table. If we are following this kind of a model, this kind of a structured model, we will call this model as a star schema design. This is connected directly to your, the data will be get passed from one side, that means primary key table side, to the fact table. Okay, directly communicating, and the data will be get filtered based on the id column. Likewise, location id to this location id of fact table. So I can filter the data based on the name of the state, name or else a state. I can see the quantity sold or else amount sold information on my particular location based. Likewise, item and branch. One more example related to the star schema for better view. Centrally, this is general example, Adventure Works dataset it is. We have a fact reseller sales in the center, which is a fact table, and surrounded by all dimension table. And completely all 5 dimension tables are surrounded in the form of one side to the many side. One side is on the dimension table side, many side, many. That means maybe the duplicates are there on the table, fact resellers table. Data redundancy is there. So I'm going to call this as a many fact table. So one to many side. So all the tables are directly connected, communicating to your centrally located fact table to see the data filtrations accordingly from each and every dimension to your fact relation. Okay. One more last example as well part of a star schema model. Please observe here, I have come up with one and star there. Fact table in the center. All the dimension tables are surrounded with one to many side. One side is on the dimension, fact is on the star. Always please keep in mind whenever if you are trying to design a data modeling part on your reporting prospect, and if you're extracting, importing multiple tables into your Power BI application, just try to check what kind of a model we are trying to build. Whether it is a star schema approach, yes, that is a good for the performance prospect, and also the readability part, data readability part. It is easy to communicate from the dimension to the fact directly. Suppose if my dimension table is having a split of data, split of subtables, subqueries are there, is going to impact sometimes. So we are going to come into that particular schema design as well. But here, all the dimension tables, if you're observing, are directly communicated to the fact and will definitely improve the performance as a part of report building. Sometimes we'll get a question like, can we maintain two fact tables and try to build it as a star schema? Yes, it is possible. We can build it accordingly. Sometimes it is not at all only one fact table. We'll try to bring two different fact tables, two different metric level information, which is going to hold, and we can also build a star schema design which is communicated to the, assume that this is one star which is communicating to your dimensions, another table which is a fact internet sales table, it is communicated to your all dimension table. There is no split here, split of dimension tables. It is directly communicating two different facts and remaining all surrounded with facts only. There is no hierarchy from dimension to the another sub dimension or else a sub table from dimension to dimension. So multiple facts also we can place it and we can build the star schema design. No issues. Still there is a myth. So we can build with a two different fact like number metric fields tables and try to bring it as a model means yes we can build it. See here, if you can try to understand the previous one as I said repeatedly, if you have a hierarchy from the dimension table to the location, like example dealer table is having a split, like a location table is there, country table is there. But location and country is not directly connected to a centrally located fact table, that is the revenue table, because it is not have any common column there, like a location ID or country ID. So in such a scenario, you have to build a model or else a schema called a snowflake, because if the split has been happened, the dimension table has been have a hierarchy and the data is getting normalized. Previously, we discussed about denormalized data, which is having the duplicates within the facts. But here, dimension table is having a normalized information like split of data with location and country. And these two sub-dimension tables are directly connected to your dealer table only, not a fact. Such type of schemas, if you are trying to design this schema design, we are going to call it as a snowflake schema. Suppose what if we can try to merge these two tables into the dimension? Yes, it is possible. We can do the merge queries in Power Query Editor. We can join it. By default is outer join, left outer join. We can join these two tables and we can build it as an star schema design. That is also possible. But maximum, we will try to see the data accuracy, data part, whether it is giving the right values whenever if I'm trying to filter from region to my revenue, like a total revenue details. I'll just try to observe for validating part. Likewise, here the product table is having a hierarchy, split of data, like a variant is a subtable, and the variant table is not communicating directly to your revenue. So it's going to communicate to the product table only based on the variant ID from product table and variant ID column variant table. So a split of information, split of additional table split is having a hierarchy. This schema design, if you have if you are maintaining the hierarchy in the dimension table, this schema design we are going to call it as an snowflake schema, hierarchy maintenance. Important, maybe who are preparing for still, I mean like preparing for the PL3 and the certification, we will definitely get some questionnaires on this snowflake or star schema model. Just to come up with one more slide related to the snowflake, because I have provided multiple slides on star schema, one more on real time, which is worked here. See here, fact reseller sales is my fact table. And if you're observing, dimension table is having three tables, subtables like dimension category, subcategory, and dimension product category. And these two tables, dimension product to the subcategory and category, having a hierarchy. Data has been split with multiple subtable, two tables. So this hierarchy, like one side on the hierarchy part, if you're observing the dimension product category, is maintaining the product category key. Another side within the dimension table, we have to bring the connection, right? Many. Here we have the duplicates, product category key. So this kind of a relationships, if you are building the hierarchical manner from within the dimension to the sub dimensions, we'll call it as an snowflake design anywhere data modeling part. Whenever you are trying to design anywhere model view. So please keep in mind, we will not work in the real-time part with one or two tables. We'll work with multiple tables. As per the project defines, we will try to extract different tables from your data source systems. I hope it is clear. If you have any questions, please post it. Yes, no. Any questions on the chat? Let me check. I will tell you that bridge tables, bridge columns also I'm going to discuss that part too. That is how we are going to bridge the bridge connections or as bridge between the two tables if you are not identify the one side to the many side. So I hope you got the clarity of what is one which is going to maintain the primary keys, what is many, right? We will try thoroughly discuss about how we are going to create a bridge tables too. Okay, fine. So see here, few more examples. As I mentioned, like I'm going to showcase to you in the real-time part, practical part. Without the sales project, sales analytics details, sales L1 project, how we are going to build the data model. Okay, let me showcase you that process on how many dimensions and so on. I'm going to ask few queries in the chat, queries now, and I'm expecting some responses as well. Hope you are able to see my Power BI model. So see here, here I have a centrally fact table. Centrally, this is my fact, and these are all dimensions: product, resellers, region, and here if you're observing region to this region, sub-region, salesperson region is having some split of data, split of information. Now, can you please help me to understand what schema design it is in the chat box, please? As per our understanding, as per our discussion just now, what kind of a schema it is? Is there a star schema we are working on or snowflake schema? Chat. Which model you are looking over on my Power BI? Responses, please. This is if you're observing here from the region, we have a hierarchy. That is, as I said, salesperson region, which is having a hierarchy. Even there is one more connection from this salesperson performance. So this is not a star schema. It is not directly connected and communicating to your fact to the dimension. It's communicating via subtables, like a region table to the salesperson region. So this kind of a models, as I said, we are going to call it as a snowflake design. What happen if you are not having any connection between the tables? Let's see here. This one also I'll just try to showcase to you. Example, sales table is there. Assume that you don't have a connection. Okay. Still, please observe if you don't have a connection between these two, what will happen? Please observe. Sales to the region. Let me try to build a quick visualization based on this sales order number, region table. Maybe I'll just try to add country column here. Okay. You will get an error because it's not defining any relationship. So if you have a proper relationship, we can see the values. If you don't have any relationship, we have to fix the cardinality. So we have to check whether what is the common column between those two. We have to identify it, and we have to bring the connection between the sales table and region table. And one more thing, please focus here. Whenever if you're importing the multiple tables into your application, there is a by default feature in the files, options and settings. Options, here we have a by default feature, auto detection is there. So sometimes for our readability part, understanding part, how it has been defined the connections, we will turn off this feature. We will turn off the auto detection of the relationships. You can see here auto detect if you are extracting some new tables. This feature we will try to turn it off if you want to understand how the model is working on. And if you are by default this feature is turned on, so in such scenario, backend, whenever you are trying to import the tables into your application, it will try to identify based on the common column headers. It will try to map it between one table to the another table. That is the meaning of auto detect new relationship after data is loaded onto your Power BI desktop application. So my suggestion is, if you want to clear, I mean like understanding part, if you want to get a clear idea how the connections are making up, you can turn off, and just try to manage your relationship based on connecting. Okay, manually you can connect it by using manage relationship. So if you can try to turn it on automatically whenever the tables has been loaded, it will try to provide some connections already. So those connections are, we are calling it as an active relationship. So in our modeling part, these solid lines, which you are observing, these solid lines, we are going to call it as an active relationship. Between table to the table, we are going to maintain only one active relationship. Let me showcase to you here. So I already just deleted the relationship between sales and the region, right? So by using this managed relationship, we can build the connection. You can build the connection just so you can observe, right? You can see here. Fix this means it is asking create a relationship. Or auto detect means if you have a common column headers, it will detect automatically. Okay, it will detect automatically. See here, like this. Automatically based on the sales table, sales territory key, region table, sales territory key is matching. So if you can try to observe which table is one side, unique records, which table is having the duplicates. If you can observe on this properties pane, we can easily identify it. You can see it on the right side. Sales table, sales territory key is having the many side, region table, sales territory key is holding the one side. By default, the cardinality, and I mean one side to the many, and here it has been detected many side to the one side as per the table selections too. And one more thing, here the data flow direction, if you're observing, data flow direction is by default, it is a single direction. That means the data is can be filtered from one side to the many side only, not from many side to the one side. What is this? What is this arrow mark? If you're observing, there is a small arrow mark is there between one side to the many side. What it is stands for basically. Let me showcase you something. So please observe here. Let me add few columns from this table, sales table only. Okay, one more table. Please focus. Region table I'm trying to select. Okay, these are the regions. Okay, please focus here. Maybe as per my model, if you're observing, I'm just focusing on the sales table and the region table. How this data flow, data pass is happening. Please observe. If you can try to select some category from this region table, I can see my data on the right hand side, it is getting filter. You can see it's getting filter. Maybe for this particular United States group North America, my data is getting changed. It's changing. Fine. So I can filter the data from one side, which is my region table, to my another side of the table, that is sales table. I can filter the information. Fine. Suppose if you can try to select something on the sales table, something is happening on the right table, that is the region table. No, the data filtration is not happening. The data is not getting flowed from many side to the one side. You can see here. I'm selecting. Nothing is happening, right? So by default, the data flow direction is from one side to the many side. Sometimes we will get a requirements from the customer side, customer prospect. Maybe they want to filter from many side. That means the foreign key table, foreign key field based to the one side. That means region table, primary key table side. In such a scenario, you can change the data flow direction from cross filter direction is there. By default, it is a single. We can change it to the both sides. Both sides, apply those changes. So you can see two arrow marks, upside to the downside, the data passes. Another one is downside to the upside. One more example, I'll just try to showcase to you, better one. Please observe here. Maybe I'll just try to showcase to this resellers on the sales table. You can open it, you can change it, or else maybe you can just try to use this properties pane and then see the analysis. Let me showcase to this. Sales table is there. Let me fetch data from this resellers. Please focus. I can filter the data from sales table to this one site. You can see the data is getting filtered on both of the sites. I can filter the information. So whenever if you are getting a requirement to see the data filtration both, you can change the cross filter direction from here on this managed relationship from both sides. Okay, fine. As I said, there are some cardinalities, right? How many types and how we are going to identify. By default, cardinality is left outer join. So see here, one to many. And these are the cardinalities. Four types of cardinalities are there. Many to one as per the table selection. Maybe if you can try to choose the resellers table here, resellers table here, and another table is sales table. It's going to be on one side to the many side, and other than that, one to one and many to many. One to one is nothing but one instance of the table is having a unique, and another table is also maintaining the unique records. That relationship, that cardinality part, we are going to call it as an one to one cardinality. And many to many is nothing but data duplication of between the two tables. We have to avoid those kind of a relationships, many to many kind of relationship. Why? In the sense, as per the performance prospect, as per the performance, whenever you are trying to do the data refreshes from both of the tables, it has to read the duplicates and try to generate the output on your visual canvas. So if it is, there is no other way, we can go with this. Otherwise, we have an option to create bridge tables too. We can create the bridge tables too, like intermediate tables, by using DAX objects like a calculated column. Suppose if I'm getting many to many relationships, we can make use of this DAX object, new table or calculated table. You can define the categorical or else whatever the key column with a distinct IDs, and we can make it as a bridge between two tables instead of generating the relationship as many side to the many. Okay, fine. One more example for you. As I said, one more is the sales related only. Please focus here. If you're observing, I have already connected with one relationship between the date table and sales orders based on the ID column date field from date table. You can see here, maybe instead of, because the screen size, you can observe here the properties part, sales order, order date to, date table, date column. Many to one is a relationship. Okay, so between two tables you can maintain only one active relationship, only one active, not more than, we will not maintain more than one active relationships. Okay, between two tables only one active. Sometimes, see here, please focus here. Assume that you want to do an analysis based on something like date from the date field. Let me add it fresh. Please focus. Let me take it as a date, calendar table date, date. Instead of hierarchy, I will try to convert this as a continuous dates, continuous dates. And total number of orders. I already created some measures for this. Let me just try to drag and drop. So for each and every day, you are observing on my left hand side, day wise orders, total number of orders. Total number of orders is day wise for each and every day, total number of orders. Fine. Because I have already built a relationship, the connectivity between the date table to the sales order. I can see for each and every day, the sales order, total number of orders for each and every day, each and every day wise analysis, right? Fine. Sometimes if you want to see, there is, we will get some requirements like, I have already holding the sales order table with the two fields already. I have mapped with order date wise date relationship. I want to see an analysis based on expected delivery date wise analysis. That means one more date field is there. You can bring it. So see here, I'm already holding the order date, right? Sales order date, sales order date is there. Let me showcase to you here sales order table, order date wise we already holding the relation. You can just try to add this expected delivery date, but here this is not what the customers they will expect. They want to see when the item has been ordered, what is the expected delivery time for this order when it has been reached, that particular order. In such a scenario, we will not visualize it, order date, and expected delivery date in the same chart or else a visualization. So we'll try to generate expected delivery date by total number of orders. How? So here we need to bring one more relation. So this relationship, we are going to call it as an inactive relationship. So if you are observing, it's showcasing something like a dotted line, right? Dotted line. This solid line is an active relationship which is already existed, and this is an inactive relationship because I want to see an inactive, I mean expected delivery date wise total number of orders, but already the relationship is exist between the date table date column to the existing order date field. You can see here on hover highlighting. But I want to see an analysis based on expected delivery date wise date. How we are going to project it, how we are going to showcase. In such scenario, we have a DAX function, user relationship function, to make that inactive relationship as an active. So I already written the DAX function. Let me showcase to you this inactive relationship. You can see here, simple. One second. Give me a minute. The screen was freeze. Give me a minute. Let me reopen it. So based on this user relationship function, we can try to define making it as an inactive to an active. So let me showcase to that one more time. Yeah. Yeah. And if you have any questions in the chat box, please post it. Let me know. The common issues, right? Whenever you're trying to build the model, ambiguity issues we will get it, and referential integrity. This is the common issues. So whenever if there is a common map, common matching between the tables, we have to cross verify whether this table is making the unique records or else the duplicates are there. We have to cross check and then try to build the data model. Otherwise we will get these kind of ambiguities or else referential integrities error. So see here, this one I'm trying to show order delivery. It's as simple as easy. So here, to make it as an active, that particular inactive relationship, total number of orders using a calculate function. Total number of orders is my first parameter passing as an expression, which is an explicit measure. It is an explicit. And here I'm using user relationship function. So how it will work? User relationship function is something which we have to call the two parameters inside. Whatever you are trying to build the relationship, which are whatever the columns you are trying to make use of it as a part of your model, you can make you can add those columns in this as a two parameters, date table date column, and another table the sales order expected delivery date time. So once we bring it, so I'll just try to showcase to you how it looks like. Please observe. Let me take a new page. Order date wise, total number of orders, and let me add duplicate this. I'm not adding the expected delivery date on this. First, I'm adding the first table chart. I'm taking here another table. Here, I have already holding the date table. I'll just try to drag and drop the date table. Instead of hierarchies, I'm just trying to showcase continuous dates. And here I will add my, okay. Let me convert this date. See here, this is based on order date. So 1/1/2013, total number of orders are 79. And the item has been delivered on next day. It is not on the same day. You can see here the difference. Second, first month 2013. Let me showcase you one more example. Please focus here. Once you built the inactive relationship, please observe here. Here I have added the total number of orders and expected delivery dates in the same chart. 1/1/2013, total number of orders is 79. And the item, the 79 has been delivered on the next day. So this is the date field, same date field. So on the next day, second, the total number of orders is 79. Here, if you're observing, this item has been delivered on the next day, 79. Likewise, third, 83 orders has been done and this 74 has been delivered on the next day. So these kind of an advanced analysis, if the customer is expecting, we will try to define in this way. You will take it and create it as a separate date table and create an inactive relationship as well. Already the existing relationship is available. In such scenario, you are going to use inactive relationship, that is the DAX function user relationship, and trying to map wherever, whatever the columns you are trying to use, those columns you have to fetch it and try to generate the logic. So here is a simple logic. You can see total number of orders wise, user relationship function, date table, date column, and from the sales order, expected delivery date wise, my total number of orders. So you can see the next day. I'll just try to showcase one more example and then will go to the next part. Fourth one, first month 2013, 42 items has been delivered. Let me just change it to the long date format for better understanding. One second. Instead of this format, this is easier to understand which day the item has been. Fourth is the Friday, 42 items has been delivered, and the previous item that day, but it is not delivered on the same day. It is delivered with the combination of 50 plus 42. 92 items has been delivered on the Monday. Sunday is a holiday. Assume that Sunday. So you can see 50 plus 42, 92 items has been delivered on Monday, January 7th, 2013. Likewise, we can see the total number of orders on a continuous. And if you want to showcase expected delivery date wise analysis, we have to make use of inactive relationship between the two tables and use the DAX function, that is user relationship function. Okay, fine. This is what, which is very important, which we will use it on regular basis too. And if you want to get created, or else if you want to add a related information of another table to many site, in such a scenario, let me showcase you one more simple example. Please focus here. Fine. Please observe. Let me discuss this thing. Warehouse related, stock related, and a sales order. Okay. And I want to add few columns into my sales order table from warehouse. So you can see the relationship is one side to the many side. One stands for, as I said, unique, start stands for many. But I want to join, or else I want to relate few more columns to my sales order table. In such a scenario, we have a DAX functions name called related. Suppose if you are referring an individual column, you can use the related. And maybe if we want to create a separate table based on the existing tables, we have related table functions too. So what I will do in the sense, warehouse stock item is there. Okay, I want to pull few columns like a tax rate to my sales order table. So please observe sales order lines table. Select the sales order lines table. I want to add a new column, right? A new column I want to get generated. And I'm going to use the function related column function. Related function will just try to define the same name. Tax rate is the new column name. It's taking some time. In the meantime, if you have any queries, please post it. Any queries?
Yes, we have
If you
a
have any
question
queries,
from
please post
Wasim.
it. This, as I said, modeling part.
We have a question from Wasim asking in star
Yes.
schema, the fact table is typically located at
Who's
the
that?
center.
Question?
Wasim from question from Wasim.
Okay, in star schema, fact table is typically located at the center. Can you explain why it is considered the best practice? As I said, yes. Yeah, I am
Yes.
reading that question. What benefits that is being to the design? What problem might be arises? So good question, Wasim. Star schema, as I said, so assume that fact table, how we are going to identify a fact table. I will tell you some tricks, as I said. Suppose if a table, if you are maintaining unique, I mean like a table which is having a huge information, like as I said, metrics are there, some number fields are there, and we can easily identify a fact table. And if you have a common connections, like one side to the many side, if it is holding multiple times on the connections part, please focus here. I mean, to identify the fact table, please focus here. Number of columns, number of columns in a fact should be less compared with other tables. Another one is, on the table should going to hold only metrics and foreign keys, that is repetition, duplicates or blanks. Okay, so it's going to have less number of, already I have written this, more number of records to identify a fact, more number of records compared with other tables. Other tables, these are the prerequisite if you want to get it identify it as a fact table. Then the next question is the same what you are asking, and how we are going to detect it, what is the benefit. As I said, if you are using a fact table in the center surrounded with multiple dimensions, the data communication between the fact to the dimension is one way, one to side, one to another side. And if you are holding the dimension itself as a subtables, that has to travel from, maybe I want to get it filter from the fact, the sales data, and the subcategory, the product table is having a categorical subcategory table, and I want to see the data passing between the categorical table, split of data to the fact will be get traveled between bridge tables. So it's going to impact and get it traveled and filter the data will be more impact. And even the data refresh runtime will be get increased. That is the main reason we will choose it as a star schema model. Okay, so always these things I will just try to follow whenever I'm trying to design a fact relationships with another table. The number of columns in the fact should be less compared to the others, and the table should have going to hold metric information, and most of the duplicates are else repetition. Another one is if the table is having more number of records compared with other tables, yes, I'm going to consider. And one more thing is surrounded with all foreign keys only, surrounded with foreign keys, FK. Okay, in such scenario these four items I will cross check whenever I'm trying to design the modeling part, data modeling activities. I hope I have answered. Any other query, Wasim? Fine. So as I said, If you're observing my model, any other question, Parth?
Yes, we have a few more questions. I think we should take at the end.
Yes.
There are a bunch of
Okay,
questions. Yep.
okay, okay. Fine. See here. As I said, I'm going to add one of the column from this warehouse stock item to the sales order by using a related function. Sometimes we will try to add to in the form of a table format, right? So from warehouse, how we are going to add it and what kind of a functions it will be get supported. As I said, related table and related functions. And if you're working on the column level, you can use the related. And if you want to generate it as a separate table by taking the reference of existing, you can use the related tables too. So here I'm giving the name as tax rate. Please focus. Related is the function. You can see the syntax as well as description too, related to the another table. So I want to bring some analysis from my warehouse stock items, that is tax rate. So just try to bring it. So instead of adding or else instead of generating, giving the visualizations part, we can try to get it added to your main table itself. So assume that if it is sales order line is the main table, we can try to get it added to. So this is one approach related. And as I said, related table is complete table level function. So we will not work on these DAX functions at all, like new column or else new measures. We are going to use new table and try to generate it as a separate table by using a related table functionality. Let me showcase you this. Mm, Let me showcase this orders does info related table. So there is a confusion when to use a related, when to use related table. If you want to, as I said, if you want to generate it as a separate table, including with some filter conditions, in such a scenario, complete table, new table, you can use a related table, which is a dimension related. Suppose if you want to generate a column from another table, which is the data is getting passed from one side to the many side, not from many side to the one side. We cannot use the related function. So if the data is passing from one side to the many side, that means fact tables related, I mean foreign key related. In such a scenario, you can use related function as well. Just now I have created in sales order lines table, I have added one new column or calculated column. So here I can try to generate maybe the state province wise analysis. Assume that it is a separate table. On the top of it, I can use the distinct or else whatever if you want to bring it. So like this is another new table, order info. It's a calculated table functionality wise I have generated. So whenever if you're working on data modeling part, please focus on how the tables and just try to cross verify the data types before working on the model data types and how the relationships, like as I said, four types of cardinalities, major focus and maximum. If whenever if you're trying to bring the model, try to get it in the form of star schema design. Maybe if you are getting in the snowflake schema design, just try to check how the data size is. Data size is very huge in the sense, then we have to check some other alternatives like a direct query approach and try to bring the info and do the modeling part as a set. And if the data size is smaller, maybe we can try to go with snowflake schema is also fine. Like that, we will follow the approaches whenever if you want to work on the data modeling part. So once the model is set right, then we will go to the next part like building the data visualizations and trying to bring some analysis using DAX logic, either it's a measure or calculated tables. Fine. I'm ready to take the questions. If you have any other queries, let me know. Any queries?
Yes, Rajendra.
Yeah.
So there is a question from Kushlappa.
Hmm.
Kushlappa is asking, okay, like what does nulls in FK column of fact table indicate?
Nulls, fact table, as I said, right? Facts, if you are holding the nulls or else it duplicates, that is nothing but it's having some duplication, or else maybe the data is not getting generated properly. Maybe we have to get check with the backend team. If it is a nulls in the sense, that should be automatically we will consider as an fact table only because it's going to hold the nulls as well as duplicate information too. Okay, blank information. Hope I have
Okay.
answered.
Okay. There is another question again from Kushlappa
Yes.
asking. In case of user relationship requirement, could we also create something like uh, shipping days equals to dated if order rated and
Exactly.
expected dated, right?
Exactly. So see here, currently, is assume that this is one of the relationship I have brought, right? One relationship, one inactive relationship, date to the expected delivery date. Likewise, maybe I want to get it visualized when the item has been shipped. So from the date, I can bring it one more inactive relationship, and I want to see the total number of orders when the item has been total orders has been created, when the item has been expected delivery date wise, I can see the analysis, and which time or else which date the item has been shipped. So we can bring one more inactive relationship, try to create an explicit measure, and try to add it in your table part so that you can see all together like date, total orders, maybe the shipping date in the middle, when the item has been expected delivery date should be available. Those analysis we can do it thoroughly. Yeah, it's possible.
Okay, so how can we judge the size of the date for choosing between the star or snowflake? Is there a
Yes.
number like number of records or a memory size?
So what is the, can you please, okay, I will read that. Size of the data. So please observe here. So as I said, right, simple trick to identify a fact table. If your data size is very high, very huge in the tables part, and the number of columns is very less number of columns, and the table is holding very key metrics, if the table is holding the key metrics like total sales amount, or else maybe if it is holding the multiple metrics, yes, that particular key column we are going to particular table we are going to call it as a fact. So coming to the star or snowflake schema, this is completely a designing part. So which flow, as I said, star schema means we can go with the joins, we can do the joins in the Power Query editor itself, like by using the merge concept, we can merge it. Or else, if you are not merging, after doing the merging, you're still getting some incomplete or else incorrected values output. Then we have to go with the snowflake schema only. We have to have a hierarchy, and data should be passes from one table to the another table. If you're observing here, this is the snowflake schema again. Start table, star sales order is there. Maybe I have one more connection of sales customer. So the data should be passed from this to sales order and to see the total order number. Okay, so the data, whenever if you're trying to design, because my sub tables information is very less, that is the dimension table. In such a scenario, you can go with the snowflake schema. We can proceed with the model, snowflake schema model. But if you have a huge information, my suggestion is you can extract via direct query connections, and backend itself we can try to combine it. Backend in the sense database level itself, we can join the tables and we can pull this information into your Power BI model. That's what I mean. As per the performance prospect, I'm just explaining. Yeah. Yeah. Hope I have answered to you.
Yep. So there is a question from Wasim
Yeah.
asking how do you handle scenarios where there are no direct relationships between the tables in Power BI?
Suppose if there is no direct connections means we have to check with the backend business team, or else we have to identify the common connections between the two tables. Otherwise, if there is no direct relationships means I mean this is all comes under the business requirement document, BRDs, right? So what relationship, what kind of a models we are going to work it on, so these are all analysis we have to do it before working on the data modeling part. So basically, we have to get connected with the backend database team and try to identify the common columns, or else maybe we'll just try to see the how these tables are related. I mean, connected to one to another, and try to bring the relationship either in the backend part, like by doing the joins, or else front end by using the Power BI data modeling way, we can perform this analysis. Yes, Wasim, hope I have answered to you.
So this is the last question from MS Swami asking when to use index column to create a relationship in modeling.
So index columns, we can create it in the both the ways. In the Power BI desktop level, using the generate series, we can get it created using generate series is the function. Or my suggestion is you can navigate and create the index column in the, suppose in which scenarios means, suppose if you haven't identified one table is having the number, another table is not holding any number, means we can create index starting from 1 2 3 and so on. But by default index in Power Query editor, it will be get start from 0 1 2 3. So you can change the numbering part here. Let me showcase you very quick. I mean in Power Query editor. So maximum we will do it the creation of new columns here only. In this add column, we can say an index column here. So you can generate the new column and try to refer this particular column. See here. By default, it will be get start from 1, 2, 3. See here. Just select it. New column will be get added from 0, 1, 2, 3. Maybe if you want to get started from 1, 2, 3 onwards, means we can change it from this series. Okay. And from there, you have to map it based on the data, like unique to unique only. If it is holding the another table also unique, means we are going to join the table as one side to the one side. That means unique instance of one table. Another table is also holding the unique table, means unique data values, means it's going to map with index to the another table index. So likewise, we are going to map between the tables and join the data. Otherwise, assume that I have an already index column is there with some repeated records. I want to join with another table which is not having any index. I can generate it via Power Query Editor. I can join it with index column to another table index column, which is going to be on one side to the many side. Yeah, clear?
I hope that answers all questions.
Yeah. Hope you like it. These are like base concepts along with mastering. So some there are a lot of confusions on the modeling part. What kind of a relationships we can use it? Which model is preferable? So that's why I have come up with this topic. So just try to go through this, and if you have any queries, you can post it, or else you can connect me in the LinkedIn as well. I'm happy to help. Thank you. Thanks, Path. Thanks for giving this opportunity.
Thank you. We have one question from Inderjit
Yes.
asking, what if we have a bridge column in star schema?
Yeah,
It
this one
will be a
already
star.
explained.
Okay.
Yeah, I have already explained this. So there is no bridge column, Indrajit. We can create a bridge tables. Just now I have showcased to you, right? By using the related or else by using this functionalities, you can create a new table. Okay, we can create a new column or else you can create a new table. Bridge table means what it is. Maybe you can explain it more on this. Okay. So tables we can create it by taking the reference of existing table only, like unique fields we are going to refer. You can create it as a distinct function or else a related wise you can create a new tables. Hope I have answered. Annie, most of the time I'm answering to your query. Star schema is preferable. Why in the sense? Star schemas are like as I said, performance prospect. It will directly communicating the data to dimension to your fact table. And if you have a hierarchy of the tables like as I said, dimension to the sub dimensions, to pass the data it should be acts like something like a filtering between one to another. That's why the reason star schema is the best approach whenever you are trying to design a data modeling part. If it is not possible, as I said, you can go with the snowflake schema and try to do the maximum data transformation activities like joining activities in Power Query Editor to bring it as a snowflake schema to the star schema. Yes, thank you.
Thank you,
Hope you
Rajendra.
like it.
Thank you,
Yeah,
everyone. Thank you so much.
thank you. Thank you.